This is 11.4 normal distributions. It's a big deal in the world of stats. Like, this is so much of a statistics class what we do today. It really, really is. We're going to start off with the empirical rule. So what you see before you is what we call a bell curve or a normal curve. And we've got some markers on the grid here. We have mu, Greek letter mu, that means mean. And it doesn't say it here, but you have a mean plus a sigma, and sorry, that should be a minus a sigma, and a mu plus a sigma. Those are 1 standard deviation away. Within 1 standard deviation of the mean, you contain 68% of the bell curve. Within 2 standard deviations, and by the way, what we usually do is we split these in little segments here. That means that each of these pieces is 34%. Within 2 standard deviations of the mean, you contain 95%. We need to put some numbers in here. So we're going to take our 95, we're going to take away 68, and we're going to get 27. And we split it into 2 equal parts, and we get that those 2 pieces contain 13.5% of the curve. All right. Then, according to the empirical rule, within 3 standard deviations, we contain 99.7% of the curve's data. So we've already accounted for 95, so we think 99.7 minus 95 is 4.7, and we cut that in half, and we get 2.35. And then you have these tails on the end, these things that are almost flatlined on the curve. But they contain 0.7%, and there's 2 tails. There's one on the left, there's one on the right. You divide it by 2, and you get 0.35% for each tail. You can just barely see it, but there's a little bit left. All right, and that is called the 68, 95, 99, 7 rule, or the empirical rule. Let's see, we have a question down here. How far from the mean does a value in normal distribution fall? 68% falls within 1, 95% falls within 2, and 99.7 falls within 3. And this only applies to normal distributions. A lot of times you'll see people say approximately normal so that you can use it, but normal. And here she is again. And just because it's that important, I want you to fill out all the numbers again. And every single problem that we do in these notes today, we are going to draw the bell curve because that's how you learn it. Three little tails, 0.35 apiece. No, not 0.35. Is that what I wrote on the last page? Something wrong with me? There's 0.3% left. There is something wrong with me. It means these guys are 0.15. My bad. 0.15. 0.15. I know that too. An example of an early application of statistics was in the year 1817, and it's a weird one too. A study of chest circumferences among a large group of Scottish men exhibited approximately normal distribution. Their chest circumferences ranged from 33 to 48 inches with a mean chest measurement of 40 inches and a standard deviation of 2 inches. Use the empirical rule to help you understand the distribution of chest circumferences in the study. What range of chest measurement contains the 68% which falls closest to the mean? So let's go ahead and put out a bell curve here. And I could have swore that I had edited these notes so that we could make this bigger, but apparently I did not. Your bell curves don't have to be works of art, kids. They don't. Just a curve. Looks like a bell. You have the mean, which in this one is 40 inches. We have a standard deviation of 2, so the next guy would be 42, 44, 46. We just go out 3 places. 38, 36, 34. This is the mean. Each of these guys contain 34%. Now we've gone out 2 standard deviations. They each contain 13.5%. Now we've gone out 3. Look back at the previous page if you need to, but they're 2.35. And then we have the tails, which are 0.15 apiece. What range of chest measurements contains the 95% closest to the mean? Well, that's the stuff that's within 2 standard deviations. That would be this, 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 and this. So measurements that lie between 36 and 44. Inches. What range of chest measurement contained the 99.7 closest to the mean? 99.7 is the 3 standard deviations of the mean. So we want measurements that lie between 34 and 46. What measurements represent the 3% farthest from the mean? Well, that 3% farthest from the mean is, or sorry, 0.3% farthest from the mean is what you get when you add the tails together. So it's measurements less than 34 inches and more than 46 inches. What a weird study. And it was one of the first ones that we did, was study men's chests. Interesting. All right, so same set of data, but here they're asking, what would you expect chest measurements to be for the 2.5% of men with the smallest chest? Of course, the issue that we see nowadays is number sense. Like the answer is staring right in front of you if you have any sense at all. Those two numbers right there make 2.5. I swear they do. If you go to a calculator and you do 2.35 plus 0.15, you get 2.5, which is exactly what I'm looking here. And I want the smallest chest measurement, so I'm going to be over on the left, not the right, the left. Left is less. It always has been. So it would be men with chests less than 36 inches. All right. What would you expect to be the measurements of the 16% of men with the largest chests in the population? So they want largest here. Well, let's see here. And the number is 16%, right? So that's going to be 13.5, 15.85, 16. That's the 16%. So I am talking about men with chest measurements larger than 42 inches. This kind of makes me want to measure my chest and see how I compare to Scottish men. I feel like I'm somewhere up there. All right, the ACT has a mean of 20.8 and a standard deviation of 5.8. All right, let's write it out. Draw that thing, man. Put the mean in the middle, 20.8. And then we add 5.8, possibly all the way to an unrealistic score. But let's see here. If we take 20.8 and we add 5.8, I feel like we get 26.6? Yeah, seems right. We add another 5.8. We'll have 32.4, I think. And normally we would add 5.8, but we kind of have to stop here at 36 because that's the max score. You can't go above 36. Maybe I should redo this problem real quick. I think I will. Let's change it to 4.8. That'll make more sense, and I'll try to remember that when I actually print these notes out, but I'll likely forget. Let's change it to 4.8. So that's going to give me 25.6, 30.2, and then 35. This makes a lot more sense. Not a whole lot of kids make above 35, and like very few do. All right, if we take away 4.8, I think that's a 16. If we do it again, I think that's an 11.2. And we got to do it one more time. Of course, man, there are kids that make below an 11. Those poor things. So I'm at 7.2, 6.4. All right, remember the stuff that's 1 standard deviation away together makes 68%, so each of those are 34. 2 standard deviations away all together is 95. We took away 68. 95 minus 68 is 27. 27 cut in half is 13.5. 3 standard deviations of the mean is 99.7. We've already talked about 95. That leaves 4.7 that we cut in half and we get 2.35. And the tails are 0.15 apiece. All right, what scores represent the top 2.5% of all ACT scores? Well, you're going to be talking about this piece of the curve right there. If you put those two numbers together, you get your 2.5%, right? So scores greater than 30.2. The top 50, you'd be surprised how many kids miss this. That's all that. That's half the graph. That's 50%, and that's the top half. And that's going to be bigger than 20.8. The middle 68, remember, that's just 1 standard deviation from the mean, between 16 and 25.6. Scores between 16 and 25.6. Now, of course, we're going to have to memorize this thing, right? Like you can expect a quiz tomorrow over this thing. It's got to be memorized. That's the goal, memorize this thing. PRB. Recent SAT scores for college-bound seniors are normally distributed with a mean score of 508 and a standard deviation of 121. Some schools use and accept SAT scores, and some districts, that's what they take is the SAT. That's a northern, East Coast, West Coast thing, not a Mid-South Bible Belt thing. We be using ACT, which used to be, in my mind, the superior of the two tests, but I kind of think they've made that thing too easy. It's really disappointing, but you know, it is what it is. Let's see, we have a mean or a mu of 508, standard deviation of 121, so I'm going to have to do some adding here. So that's going to be 629. I'm going to add 121 again. It's going to be 750. I'm going to add 121 again. It's going to be what, 871? And then I'm going to work my way to the left. Remember, you just do this 3 times. So what am I taking away here? 121? That's a little harder to do. It'll be 408. And then I lost myself here. 390. What am I missing here? 387. Seems legit. 200 and what? 66. And then finally for the dumb there at the very bottom there, you got 100 and what? 45. I think those numbers are right. The kids who get this, they draw the bell curve. The kids who don't. That's really the reality of it. Like it just boils down to, are you willing to draw the bell curve or not? Which is why I always write, you must draw the bell curve. I'm not going to give you the choice. There you go. There's your nice range. What percent of students had scores higher than 387? That's going to be all of this, right? Now, I know that this stuff right here is 50%. And 50 plus 34 is going to be 85. Sorry, 84%. Easy peasy lemon squeezy. And that was actually it for the first part of 11.4. Hope you enjoyed.